You know, CO2 is actually denser than the atmosphere is, so if you let it go, it wouldn't go up, it would go down. Not only that, but carbon dioxide, when it touches water, it breaks down into carbonic acid, and then it releases hydrogen ions and becomes bicarbonate, which means if you're going to drill for ice cores, looking for carbon dioxide, you already know for a fact that that's not where you're going to find it. If they try and say it captured it in the air, understand that when anything freezes, it always freezes the outer layer solid and then freezes inward. Not only that, it has less specific heat than air, and also carbon only makes up 0.025% of the Earth's crust and 0.04% of the atmosphere, which is pretty peculiar if trees are like half carbon by weight. We're mostly carbon, apparently, like we're carbon life forms. Although you require silicon for your hair, for your bones and joints, for your connective tissue, for basically just about every part of your body requires silicon. It's in your food, and silicon is 27 point something percent of the Earth's. It's the second most abundant element after oxygen. It also happens to be right here. Right here, if you look at that ingredient, you see the calcium silicate. Yeah, calcium silicate, or silicon dioxide, basically. Silicon and oxygen, that makes sense. But aside from that, let's move on to the Earth, right? You've got this whole idea that the moon is causing 2 high tides a day. You know, the moon only tracks about a half a degree across the sky per hour, which means that, you know, in 20 hours, it's not even, and it's only been 10 degrees. And it's usually there all the time, which is why you see it at night and during the day when the sun isn't there. So how does it cause 2 high tides a day? Regardless, how is it reaching past the atmosphere and picking up the ocean? You'd have to pick up the air first. The air, which weighs 1.25 kilograms a cubic meter at sea level. Yeah, why wouldn't that move its way up toward the moon way before you end up picking up the ocean? Every planet seems to reflect tons of light and is extremely bright, except for Earth. Earth is like this pale blue dot from a distance, which is crazy because on the surface of the Earth, you can look up into the sky and you can see like all of the planets, all of the moons. Everything looks bright as hell. Matter of fact, even Galileo looked at the moons of Jupiter and called them stars, basically. Then someone decided to call them moons after the fact. For whatever reason, whenever, you know, we get closer and closer to space, basically less and less atmosphere, we are able to see so much more, right up until a point where they put a camera on a rocket and then it all goes dark. It all goes dark, it all goes black, but somehow you can still see the Earth and the moon perfectly. None of the stars, none of the stuff in the background, but whatever. Anyway, Earth's got this like liquid churning magnet, apparently, like its core is somehow a magnet that has poles, basically, because that's how magnets work, and it doesn't somehow come together. And they say it's freezing outward from increased pressure and temperature, which is crazy, because when you apply force and heat to a crystal lattice and it turns into a liquid, those molecules go from having space to no space, to rubbing against each other. So for it to then return to a solid under more doesn't really make any sense, because then somehow the crystal lattice would have to re-expand. But you know what makes more sense than a liquid churning magnet and, you know, freezing materials by increasing the temperature? When we ground our wires, that's positive particles that are flying straight down, right? And then electrons are jumping out of the sky. We see that as lightning. There's like 150 volts between my feet and my head, based on the voltage potential with respect to altitude. And you think to yourself, well, if there's natural current, right, because there's molecules, right, and if they're moving up, or if there's just lightning jumping out of the sky, you know, jumping into the sky, maybe that flowing current creates a magnetic field, because that's just what current does. And you got to think to yourself, if particles are grounding, right, they're going into the soil, they're not just hanging out there, right, they're probably on their way somewhere, which means eventually they're probably going to end up colliding into the core. And in a collision, there's this thing called the elasticity of a collision, which basically means all of the kinetic energy either gets converted into some portion of heat or gets reflected back. And since since it's a completely inelastic collision, all of that heat, the extra mass of the particles, it actually kind of makes a little bit of sense here, which also makes sense because other planets like, Jupiter, like Saturn, they have like this flux tube, right? These charged particles that flow between them and their moon. Apparently we don't have that, but all of them do. And they also have a plasma torus. We don't have a plasma torus. We just have this thing called the Van Allen radiation belt. But whatever. What's funny is, like, they always tell us that if the planet gets warmer, then that's going to make storms worse. but it's buoyancy effect that affects wind speeds. And if you look at like Venus, 460 degrees Celsius, that's 4.6 times the boiling point of water. Its wind speeds aren't very impressive. But if you look at every planet that has an atmosphere that's colder than us, you know, basically Mars is the only one that doesn't have enough atmosphere. And so if you look at, you know, Jupiter with the giant storm, if you look at Saturn, Neptune, all these really, really cold planets have ridiculous wind speeds, some of which break the sound barrier because, you know, buoyancy effect. So what's weird is that somehow light from the sun, like, you know, energy from the sun, makes its way through the atmosphere. Some of it gets moved by the magnetic field, which, if our weak magnetic field can move tons of high energy particles from the equator all the way to the poles, you think that that would be a really, really good way to transfer energy here. Since it's such a weak magnetic field, we should be able to do it for less, right? Well, anyway, some of it goes to the poles, you know, just arbitrarily. Some goes to the north, some goes to the south. Some rays make their way in. Of those rays that make their way in, somehow they reflect back out, and some of them make their way out. Some of them bounce back because of the, you know, the greenhouse gases, which is weird because, you know, water, which makes up most of the planet, doesn't really reflect light so much as it absorbs it. Most places absorb light, but when you do some basic calculations and you think about all the energy, the heat and stuff that's being released off of our bodies, basically you go outside and you start sweating, right? And there's charged particles in the atmosphere. Just like I said before, right? There's about 100 volts difference per 3 feet. And if you start to sweat or heat, right, the heat makes the gas expand. And so as the gas expands, that's basically there's charged particles in the air. The charged particles are moving outwards, so that's like expanding the plates on a capacitor. But due to buoyancy effect, it just has to go up, which creates current. Think to yourself, well, if stuff reflects off of the atmosphere, because they said it happens, and also we've been bouncing radio waves off the ionosphere since like way back when, to send, you know, transatlantic signals. So once you do the calculations, you see to yourself, it's like, oh, you know, it makes way more sense is that all the biolife and circadian rhythm and the fact that there's like this linking between all of us and this field, and you recognize that all of the energy that we're releasing has to go someplace. And if it was to reflect back, it would actually make more sense, because that would cause the whole sky to look blue. The idea that the sun is the source of the light, but then somehow it makes the entire atmosphere like blue.
Does it literally even make any sense? Because we know that the further away it is, right, the more atmosphere it has to go through, right, the yellower it is.
So somehow it's still able to do all that blue. Meanwhile, somehow the moon is reflecting light from the sun. The sun, which is yellow, the moon's giving us white light. That means somehow more colors are coming from the moon than are coming from the sun. Start to recognize that things like light pollution don't make a lot of sense unless you understand how the power grid works with our neurobiology. That's another video. And how just a bunch of people on top of each other, a bunch of electric power, like all of that energy being released, that has to go someplace. The idea that we have these light bulbs that can barely, somehow these light bulbs are doing basically the street lights and the apartment lights or whatnot are doing what the moon itself literally can't, because the moon doesn't even cause the sky to light up like that, but light pollution does. Also, some things that don't make sense, right, is that if Venus is 460 degrees Celsius and all of its energy comes from the sun, then how the hell is it also bright as hell? Because there's this basic thing called emissivity. Either you're reflecting a certain portion of your light or you're absorbing a portion of it. For you to reflect it and come out to be that bright, that means you're reflecting basically all of it. It's like, you know, aluminum foil, or the difference between that and a black body object, which is darker and warmer. Only other way to be bright and have all of that heat is to be generating it. And back to the whole CO2 idea, why do we want the planet to be colder? Like, even polar bears, even they only survive off of what comes out of the ocean, because nothing grows on ice. You know what I mean? Like, if you go to the hottest places that are wet, there's always life. You know, and then the more plant life you have, the more bug life, the more insect, more every life you have. And so the idea that you want more ice means you want even the polar bears to starve to death. And they still won't plant trees, even though that's the solution, huh? Thinking it's just pyrolysis.